एक्चुअली मैंने सर को बोला, मैंने कहा सर वो कल ना ये बैकग्राउंड में नहीं दिख रहा था ना, तो ये अब दिखता रहे हर टाइम पे तो समझ में सही रहेगा। लाइव में हमें कैसे समझ में आएगा सर हम आ गए कि नहीं आ गए, आप वो बता दीजिए। लिंक भेजा आपने?
यस सर लाइव आ गए सर। वो मैंने कल ही से ले रखा है ना सर, वो मैं उसी पे आया ना आपसे। हाँ सर, मतलब सर चैनल तो वही रहेगा ना सर? हाँ सर, तो वहीं पे सर देख ले सर, ऑडियो भी है। यहाँ पे सारा ऑडियो ही।
अभी ऑडियो सर म्यूट कर दीजिए, हमें लग रहा है अभी वो ठीक नहीं है। हाँ मतलब टेस्टिंग चल रही है, इसीलिए मेरे सर को बोला सर जब हम लोग बिल्कुल रेडी हो जाए ना तब। ये बच्चा था, ये कौन है? अच्छा अदिति जरा ठीक है, इन्हीं का तो है ना पहले। अरे
Yes, sir. Sure. I will check, sir. Okay.
Yes, sir. Right, sir.
Education is not the learning of facts, but the training of mind to think. As stated by Mr. Nelson Mandela, education is the most powerful weapon which you can use to change the world. The roots of education might be bitter, but its fruits are always the sweetest. As we all know, education is simply the soul of a society as it passes from one generation to another. So, here we are contributing our fair share of efforts. A very warm and healthy good morning to all of you. I, Aditi Karsolia, on behalf of entire Electronics and Communication Department, take this privilege to thank everyone for participating and attending First International Conference on Recent Trends in Parallel and Distributed Processing Techniques, organized by Department of Electronics and Communication, Galgotia's College of Engineering and Technology. I am very delightful to announce the successful completion of the first day of our conference, which was welcomed and inaugurated by great number of colorful talks, which included interactive sessions on the emerging technologies in the field of parallel and processing research, artificial intelligence, and whatnot. Firstly, I would thank our patrons for nurturing this institute to immense heights of excellence. Shri Sunil Galgotia, Chairman GCET, Mr. Dhruv Galgotia, CEO GCET, we would like to extend a special honor to our chief guest, Engineer Wong Chang Jong, Designated Senior Manager, ICT Talent Development, Asia Pacific Region, Huawei Technologies, Singapore. We are also obliged to thank Dr. Brijesh Singh, Conference General Chair, Dr. Lakshmanan M., Convener and Conference Organizing Chair, and Dr. R.L. Yadav, Conference Chair. Now, I would like to hand over to Engineer Gaurav Pawar, sir, who will speak on the topic Optical Network Technology and Scope of High Capacity Network Designing. Sir is a competent professional with quality and varied 10 plus years of experience in telecom. Engineer Gaurav Pawar, sir, is a subject matter expertise in optical transport technology domain. He has also worked on major projects such as Gale Network Upgrade, Reliance Jio 4G Network Implementation, 4G Network Planning Punjab Circle, Bharti NLD 4G Network Implementation. He was also involved in North India Vodafone Idea Long Haul Network Planning. Talking about his personality, he likes to keep place of work joyful, love collaborating and helping co-workers and partners. Pawar sir delivers value and growth for customers, organization, stakeholders and partners. He is actively working with NGO Nai Roshni to provide education in rural areas. Now, I'd like to welcome sir to the speaker panel. Welcome, sir.
Thanks, Aditi, for such a warm gesture. Good morning, all ladies and gentlemen and dear colleagues. Hi, I am Gaurav Pawar. Pleased to be a part of this first international conference on recent trend in parallel and distributed processing technique, organized by Department of Electronics and Communication, Galgotia's College. I also want to express my sincere gratitude to Honorable Chairpersons, Chief Patron Shri Sunil Galgotia ji, Mr. Dhruv Galgotia ji, Dr. Vinay Pathak ji, Dr. Vijay Singh ji, Lakshmanan sir, R.L. Yadav sir, and Amanpreet sir for providing such a platform to exchange knowledge with you all. I am sure you will have a fruitful and rewarding exchange in the next few hours, and I am here to deliver the knowledge sharing on the topic optical network technology and scope of high capacity network designing. So before I starting, I want to check I am audible. No? It's nowadays it's a routine
Yes,
check
sir.
to check this.
Yes, sir, you're completely audible.
Okay, okay. Thank you. So I'm presenting my screen to you all. So it's visible, my screen?
Yes, sir, it is visible.
Nice, great. So today's topic will be the optical network technology and scope of high capacity network designing. Okay. So dear students, I will start from the networking types and the transport network we cater in our network. So there are three types of network, that is long haul network, access network, and metro network. So this is the diagrammatic representation of these three networks, that is long haul, metro, and access. On the top of the layer, there is a long haul network, which usually interconnects the major cities like Ahmedabad to Mumbai, Mumbai to Delhi, Mumbai to Kolkata, and vice versa. So to connectivity between these cities, we use long haul networks on a fiber system. Then there is a metro network, and the end user, there is an access network. So the traffic originated from the CP customer. Just a minute. Okay, so the traffic started from that end premises, goes to access network, and this will converge all the traffic and will hand over to the metro network. Then on a large scale, on high bandwidth, metro will converge the bandwidth and it will hand over to the long haul network. So what is long haul network actually it is? The long haul networks are the core of the global network dominated by a small group of large transitional and global carriers. Long networks connect different cities, like I've earlier said, like Mumbai to Kolkata, Mumbai to Delhi, Hyderabad to Bangalore, Hyderabad to Chennai, and etc. So their application is to transport, and their primary concern is capacity, because to cater the bandwidth between the two cities, there is a huge bandwidth demand. And in earlier stage, in early of 2000s, there is a bandwidth STM1, STM4 that is of 155 Mbps, 624 Mbps is used to cater. But nowadays, it is upgraded and required 400G networks in long haul network. I will discuss in detail. For example, this is a long haul network between Lucknow and Noida. So it is connected via fiber, and there are three types of sites in this. So at major junctions that like Lucknow, Noida, Mumbai, Bangalore, there are terminal locations. In between there are Ola locations, and one site type of is Rodam. So I will tell you brief later on. So terminal is like we have to deliver the bandwidth to end users. Like you have heard about the cable operators and the internet service provider, Hathway, ACT. So they demand generally bandwidth from the operators, and we used to deliver this bandwidth at these terminal junctions like Lucknow, Noida. So what are these three types of sites? First is terminal site. A OTM site adds service signals to the lines of the WDM system through the multiplexer unit. It also drops the service signals from the lines of WDM system to the demultiplexer unit. So basically, terminal sites are the end sites at long haul network and used to drop the traffic starting from the 1G, 2G, 2.5G, 10G, and maybe 100G, depending upon the requirement of end user customer, which may be institutionals and organizations or cable operators or internet service provider. In between, there are ROADM sites. It is term sites reconfigurable optical add drop multiplexer. So in this diagram, you can see here we can add or drop or this ROADM side is used HF switching. I will explain later on. And then the third is OLA. So OLA is nothing like a booster of a signal. In this here, if a signal starts traveling from Lucknow to Noida, so after some extent, signal will deteriorate. So to boost this signal and regeneration of this signal will be done by optical line amplifier side. Okay. So second is metro networks. Between these two large and different networking domains like MANs, the network channel traffic within the metropolitan domain and between large haul point presence POPs. So between the access and long haul networks, there is a metro network which converges all the data from access layer and hand over to the long haul network. Okay. So third is access network. Access network are the closest to the end users, I have earlier said. So at the edge of the MAN, they are characterized by the diverse protocols and infrastructure, and they span a broad spectrum of rates. Customer ranges from residential internet users to the large corporation and institutions. The predominance of IP traffic with its inherently bursty, asymmetric, and unpredictable nature presents many challenges, especially with the new real-time application. At the same time, these networks are required to continue to support legacy traffic and protocols. So this is a pictorial presentation of long haul network, metro network, and access network. So starting from here, like there are the business segments, offices, schools, institutions, government offices, enterprises, and different zones, which required internet connectivity. So from there, it is converges to the access layer. So these access rings are lower capacity like 1G, 10G, maybe 40G or 100G. So we are delivering the bandwidth from these access layers. So while after going this access layer will converge the data and send it to the bigger layer, larger set of layer, that is metro layer. So like in a state, there will be multiple of access rings, access network, which will carry the traffic, and at one point it will aggregate to a one point and it will hand over to the larger layer, that is metro layer. After this metro layer, it will be a connectivity to protect these access layers, and it will also converge the data, bandwidth, and it will hand over to the long haul network. Long haul network ultimately goes to the internet exit points, which may be one or two depending upon the operator scenario. So at the top of the networking diagram, we have long haul networks, then there is a metro network, then third is access networks. So moving to the next slide, I will tell how to increase network capacity or how this demand arises in telecommunication system to expand and use this exponential growth of bandwidth. First of all, there is a SDH network in early 2000s. So at that time, rate was STM1, STM4. Okay. Then the technology evolves and converts to TDM, that is time division multiplexing. In that, the basic payload rate is STM16 and STM64. This is cost and complication. Then next technology is WDM, which is started earlier in 2008, and this is economical and mature and quick. After that, nowadays we are using OTN technology. In this, we can use a single line rate up to a fiber, that is 100G channel, 200G channel, and 400G channel. It's a combination of all. OTN is optical transport network. This is a combination of SDM, TDM, and WDM. It is a multi-service and robust capacity carrier network. So I will talk about basically these two technologies, WDM and OTN, because SDH and TDM are now obsolete technology in telecommunication. So to cater high bandwidth, currently we are deploying OTN networks. These are the smart networks, and a single box can carry all type of services. So what is WDM? WDM is basically wavelength division multiplexing. Okay, so if you recall back in the physics classes, we have read about the prism, this Newton prism experiment. So the phenomena where prism separates white light into a variety of monochromatic light called as a dispersion. Same phenomena is used in telecommunication department. Like if we are the signal carries on a fiber as a gray signal, that is a black signal. After that, entering into the system, it diversified to the multiple channels, and depending upon the channel spacing, we can use the number of channels. It may be 40 or it may be 80. Similarly, like what spectrum is doing. So white light can be decomposed into different color of monochromatic light, and this monochromatic light can be combined into one white light. Similarly, when a signal, optical signal, starts from the terminal location, it is a black light. It travels as a black light whole through the destination. Like from Lucknow, it started, then Ola, it is a black, black, black. Then when Noida, it enters, then in WDM system, it will split, and it will split the number of channels as per the requirement, as per the design. So, what is the background of WDM? With the boom of various new services and more bandwidth required nowadays, so WDM is very critical. With SDM, SDH technology, new multiple core optical cables can be laid. With TDM technology, the bit rate increase. The bit rate ranges from STM1 to STM64. But in WDM, multiple signals are transmitted through one optical fiber, and it can cater 100G to 400G channel. So I will tell you the rates in terms of capacity. What I am talking about STM1, 4 and 16, how much is the capacity of a one signal? So in SDH, in early 2000, we are using STM1, that is only 155 Mbps. Can you imagine? We can deliver end-to-end customer only up to 155 Mbps. After that, technology evolves. Then STM4 came in the picture, 622 Mbps, then 16, 2.5, then STM64, 10 Gbps. Okay, but nowadays we are using OTN rates. It is a combination of SDH, VDH, and TDM and WDM, in which the signal rates starts from OTU1 to OTU4 to OTUCN. So what is OTU1 basically, and what is OTU2 and OTU4? So there are different type of signal rates, and depending upon the requirement of the customer, we can define the OTU rates. For example, if our end customer requires only 2.5G bandwidth or 2 gigabyte bandwidth, so we can deliver OTU1 to that customer. Okay, if the customer is on a larger scale like Facebook, Google, Amazon, or any other OTT players, Netflix, which are requiring 100G bandwidth at a particular juncture. For example, from Mumbai to Kolkata, they require 100G bandwidth, so we can give OTU4. And previously it was not possible. Nowadays, with this enhanced capacity and the complexity is reduced, and with this OTN, we can use this OTU4 rates. Okay. So guys, what is WDM system? WDM system is similar to the highways. For example, I have earlier told that Lucknow to Noida, you have to travel the signal. Okay. So there are multiple cars. I am telling you just example, multiple cars, and in terms of telecommunication, they are payloads. There is a 10G signal, 40G signal, and 100G signal. There are 3 different cars traveling on a highway from Lucknow to Noida. In between, there are gas stations on highway. So in WDM system, we call it as a OSC. So patrolling car is a OSC, gas station is an Ola. Okay. So when signal starts from traveling from here, then after some extent, the signal deteriorates. Like car needs petrol after traveling some kilometers. Similarly, a signal starts to travel from here, then there is a gas station which is called Ola, optical line amplifier. Signal need to be boosted up. Okay, the signal strength deteriorates after traveling 60, 70 or 80 kilometers. So after regenerating this signal, it can travel again 70 to 80 kilometers. Similarly, like the car. Okay, so there are multiple lane highways on a highway. So in WDM system, this is a single fiber, and we can deliver multiple channels of rate 10G, 40G, 100G, or it may be 100G, 200G, or 400G, or it may be unique 100G, 100G, or 100G, like this. So this is signal traveling and reaching to the endpoint. So what is WDM fundamental? A single gray light starts traveling from a terminal point. Okay, so at a WDM site, what happens, I will tell you. A single gray light enters in O2 system and it will demultiplex the signal in colored signals. Okay, so there is a single fiber coming from other side. Okay, as soon as it enters into the WDM system, it breaks up to the number of colored channels and of different frequencies. So this frequency distribution I will discuss later. What are the frequency availability in C band? Okay, so it will demultiplex these channels, and again it travels to the mux to demux, and it can add or drop wavelengths or add or drop client rate depending upon the requirement or that particular site. And after that again all happens, it demultiplex the signal into a gray signal and it will travel to the other side. So there are two types of system. One is DWDM and one is CWDM. Generally, we are using DWDM in our telecommunication network on optical fibers because of availability of high number of channels and a high number of channels and capacity catering. In CWDM, we can use only 5 frequencies and so limiting the bandwidth also. What is the key technologies in DWDM system? First is optical source, optical electrical detector. Okay, so what is optical source? It transmits the signal. So when it starts transmitting, then it will go to the system and it will travel to the other side. Then optical amplifiers, like I have earlier said, there is a need of signal regeneration after a extent, because after traveling 50 to 80 kilometers some distance, signal deteriorates because of the noise, interference, attenuation. So because of these the impurity factors, signal deteriorates. So we need optical amplifiers. Then wavelength multiplexing and demultiplexing. What do you mean by that? That a signal enters the system. So demultiplexing will demultiplex a gray light into number of channels as per the requirement, and after that we can add or drop the signals. Then again, while going out to that system, we can multiplex this signal into a single gray light. Then supervisory channel. What is supervisory channel? This is like a patrolling car, I have earlier said. So it will manage the entire network. Like if you want to see the whole network, it will comprises how it looks, how you can perform the performance monitoring, alarm monitoring. It is done through the NMS. NMS means network management system. In our system, in laptops, we have this access of NMS where we can see entire network, the management of NEs. We can manage any NEs through NMS, and it is done by this optical supervisory channel. What are the main components of WDM? The main components are OTU, okay, multiplexer, demultiplexer, optical amplifier, OSC. So this is wavelength range in WDM system. We have 6 number of bands in our spectrum, that is O, E, S, C, L and U. O means original, E means extension, S means short, C means normal, N means long, and U is ultra long. Okay, this is the frequency range. The frequency is for O band is 1260 to 1360. For E it is 1316 to 1460. For S it is 1416 to 5025. For C 1525 to 1565. And for L 65 to 1625. In our telecommunication system, we are generally using C and L band, and more primarily we are using only C band. Why we are using only this band? Because of low attenuation factor and the noise impurities and the degradation in fibers. In C band system, what the hardware we are using in C-band, the attenuation is minimum in comparison to other bands like O, E, S and U. So if you have less attenuation, that means the system you require is less complex and less cost bearing. Okay, so for the amplifiers we are using Alpha and Raman amplifiers in C band will be less cost effective. And if we want to use these bands, we need more complex system which have more attenuation and duration of signal will be more. Like in C band, signal can travel up to 60 to 80 kilometer. But if you use this S band or E band, the signal traveling distance will be very less. And we need multiple of hardwares in a single span. So that's why we are using this C band more precisely. So this is the number of channels present in C band. Okay. So the C band frequency range is 1525 to 1565 nm. And if we terms about frequency, then we can use the channels 40 or 80 depending upon the frequency spacing. What is frequency spacing? Like first channel we using in C band is 192.1 terahertz and it's corresponding to 1560.61 nm. Okay, so like second frequency will be 192.2 in terms of 40 channel. If we are using 80 channel system, then the second frequency will be 192.15. So the difference between first and second frequency is 50 megahertz, 50 gigahertz, or it may be 100 gigahertz. 100 gigahertz in terms of 40 channel system like 192.1 and 192.2. So there is a channel spacing of 100 gigahertz and for this 50 gigahertz. So channel spacing basically decides number of channels we can use over a C band. Okay, more the network evolving to the higher bandwidth requirement, this channel spacing to be reduced to cater high bandwidth. For example, like in C band system, we can use 80 number of channels with frequency spacing of 50 gigahertz. Okay, so there is a question in your mind that we are using more channels, how bandwidth, more bandwidth can be provided. So I will tell you friends that one number of frequency that is 192.1 can carry 100 Gbps or 200 Gbps or 400 Gbps bandwidth as per the system requirement. So if you are using 80 channels in C band, so we can multiply this 100 Gbps signal to into cross 80. That means 100, 100, 100, 100 up to 80 channels. So this much amount of capacity we can cater over a C band. So you can imagine with this OTN technology how much bigger, wider perspective we can use this bandwidth. And this depends upon the system. Like what is the latest technology we are using? Coherent system, ADC technology. So these are contributing to the this system. Like previously we can only use 40 channels, 20 channels. How we are using 40 channels? Like the frequency spacing is more between the two signals. That is called guard band. I will discuss in brief. So what are the advantages of WDM? This is ultra high capacity, data transparency transmission, long haul transmission, compatible with existing optical fibers, high performance to cost ratio, high networking flexibility, economy, reliability, and smooth expansion. So what is the difference between CWDM and DWDM? CWDM abbreviation means coarse wavelength division multiplexing. DWDM is dense wavelength division multiplexing. I earlier told in CWDM we can only use 4 to 5 frequency channels only, but in DWDM we can use 40 to 80 to 120 or 160 number of channels, and this one channel can cater bandwidth of 100 Gbps. So in CWDM, if we are only using 5 channels, that means we can deliver only 500 Gbps bandwidth to the system. But over the course of time, in WDM, we can use 40 to 80 channels. So in terms of capacity, DWDM has a superior hand over CWDM. CWDM greatly reduces the system cost while providing certain amount of wavelength and transmission distance within 100 km. In CWDM, number of channels is few and cheaper hardware. No amplification, a lower cost system and distance limited system. In CWDM, no amplification required because the number of channels quantity is very less. But in DWDM, amplification is required that need to be taken care by the optical amplifiers, alpha amplifiers, Raman amplifiers. So I will tell you discuss about the OTN technology. That's all about the WDM technology. Now I will discuss about the OTN technology. This is the latest trend that we are practicing in our system, and this gives enormous growth of cater the bandwidth. So now I will discuss about the MS-OTN. So what is MS-OTN? It is commonly called a digital wrapper. Optical transport networking is a next generation industry standard protocol that provides an efficient and globally accepted way to multiplex different services onto an optical light path. In telecommunication industry and service provider, network must quickly evolve to deal with this explosion of digital traffic driven by multimedia services, mobile applications, social media, voice over, internet protocol, and cloud computing. Plus, there is an ever-growing array of bandwidth-hungry applications. For example, nowadays we can play online gaming on a live platform. Previously, it was not possible. We have to download the games and we can play. But nowadays, we can live stream. The people sitting here and in New York, you can play game on a real-time scenario. Why? Because of evolution of the high bandwidth scenario. Okay, we can buffer the videos on live basis. On the other hand, in early 2005 or 10, there is only 2G, GPRS, as what we call. We cannot live stream the videos. Okay, so today, now we can live stream videos because of this high bandwidth. And going forward to 5 to 10 years, we will see smart robotic systems will work for us, and we smart enablers. The system is developing, so it on live streaming basis, it will work on. Okay. So network traffic is used to be all about the voice calls carried over the circuit-based networks in predictable network connection between the pair of endpoints. So this is the diagram of OTN. Okay, MS-OTN we call multi-service transport platform. So there are different technologies, SDH, TDM, WDM. So what is OTN? It is a digital wrapper. Okay, all the services can be groomed in a single box and it can cater large bandwidth. Okay, so at a particular juncture, if you use to SDH technology, TDM or WDM, so we require different boxes like switch, MST, WDM. But in OTN, it is a digital wrapper. In a single box, we can cater all these type of services, and this is a very smart system. It can do switching based upon the requirement. It can add or drop traffic of multiple rates. Like if a customer requires 2G bandwidth or 10G bandwidth, we can use the ports rate as per the requirement. But previously, the port rate of the system is fixed. Like the OEMs supplies only fixed baud rate, like 10G, 100G ports. But nowadays, we can use as per the requirement. A 10G port can be used as a 2.5G port, or a 100G port can be used on multiple line rates. Okay, so this is the advantage of OTN. flexibility. So, what are the standards, ITU standards of this OTN network? The network architecture is basically G.872 and the physical layer is 0.692, 0.959.1 and the structure and mapping of this OTN is 0.709. Equipment management 0.874. What do you mean by equipment management? In a OTN network, there are different types of site that I have told, the terminal, regenerator, that RODM, that OLA. So all these network equipments to be managed on a common platform, that is NMS, and that can be accessed by the certain number of users to perform alarm monitoring, to do the required changes, configuration management, or to perform the upgradation. So on this NMS, equipments are managed through this standard .874. Okay. So data and signaling communication network is .7712. Laser safety is .664. What is laser safety? I will tell you. Like there is a SFP pluggable module which transmits the optical laser. Okay. So it transmits the optical laser and starts the signal traveling. So this laser safety is nothing like there is a mechanism ALS, automatic laser shutdown. If there is a high power receiving at the receiver port, so there is a threshold value to be set at the laser port, and that is basically refers to the laser safety. So what is this OTN framing? How it is, why it is called digital wrapper? So it is a combination of SDH frame, STM14, and ultimately logical connection, that is VC1416. Okay, then Ethernet tributary, 10G channel, 40G channel, 100G channel. This refers as a packet. And then there is a OTN mapping. It contains all types of signals, STM, packet, video, FEG, with terms as audio logical connections. All these connections, audio for OTN mapping, packet for 1G, 10G, 40G signals, and VC4 connection, that is logical connections for SDH frame, are wrapped in a single pipe. Okay, that is a universal line, and this is called OTN framing. And this signal and the endpoint terms as OCH. Okay, which we also refer as a lambda. So this lambda can be in terms of rates of 10G, 40G, 100G, 200G, and 400G. So over a single fiber, we can cater multiple of OCH that carries the bandwidth of 100G, 200G, or 400G. So this is the traditional and universal line board. Okay, so what is universal line boards? In a single board, we can carry multiple wavelengths. Okay, so audio, VC4s, and packet. Like here I have shows. Okay, this is in a single board, OTN framing is done. So there are terms arises audio and OCH and OTU. Okay, so I will tell the difference between audio and OTU. Just a minute, sorry. So audio is the basic payload that is electronically groomed and switched within an OTN network, and the OTU overhead add bytes to the provided optical sections, layer performance monitoring, alarm integration. Basically, OTU is nothing, just it adds the payloads of to enable performance monitoring or FAC or alarm indication, that the GCC bytes added on the optical section. Okay. This is the signal flow diagram of a WDM network. This is the terminal side, which I have earlier showed you. This is OLA, optical line amplifier, then again terminal side. So for example, if I will say in terms of city, this is Lucknow. In between you have Sitapur, Agra, or whatever it is, then there is a Noida. Okay. The signal start traveling from the OTU to the multiplexer to the optical amplifier, to the fiber interface unit. Okay, then there is a OSC that I refers the patrolling car, okay, which uses to management the system. After signal start traveling from the OTU to this endpoint of that Lucknow junction, then this OSC signal will also travel and it will reach that particular Ola side. This signal after combining, that is let us suppose Sitapur. Okay, in Sitapur this signal will combine this and again it will like this and it will reach to the next Ola side. Here amplification will start for the signal with the application of this optical amplifier, like signal starts and travel up to 60 to 70 kilometer. It needs amplification because the duration of the signal. So this will be taken handled by this optical amplifier like this. Again, OSC channel is also regenerated. Okay, again it will combine at the endpoint and it will go to the Noida like this. And here we can drop the signal and ultimately to the end user. So signal starts from here to Lucknow and drops at the Noida. So this is the signal flow diagram. So what is the OSC working mode like for patrolling car? So a separate wavelength is assigned to the OSC, that is 1310 nm wavelength. Okay, and it should work when optical amplifiers failed. This OSC should work and tell the users NMS that boss, there is a problem, there is a fiber cut and I cannot reach Noida via this path. So this should be taken care by the OSC. It supports the long distance transmission, bidirectional transmission function with this piecewise. What are the advantages of OTN? It is a multi-service, as I earlier said. It is a combination of SDH service, WDM service. So by allowing multiple clients, packet of multiple rates, VCs, logical connections, and the video, etc. So multiple clients to be transported on a single wavelength. OTN provides an economically mechanism for maximizing the use of DWDM capacity. Second advantage is determinism. OTN indicates a specific and configurable bandwidth to each service, group of service, or each network partition. This means that the network capacity and managed performance are the guarantee for each client, and there is no contention between the concurrent services of users. Third is facilitates IT and OT convergence. Okay. So the ability to partition an OTN switched network into private network partitions, also referred to optical private networks, OVPNs, for a dedicated set of network resource to a client independent of the set of the network. I will tell you the example, like OTT player or organizations need partition of the bandwidth like in 10 segments, and it wants do not interfere these partitions to talk to each other. And this will be handled by this OTN technology. Okay, so it is worked as an optical virtual private networks. Fourth advantage is flexibility. OTN network gives operator the ability to employ the technologies needed now to support transport demands while enabling operators to adopt new technologies as business requirement dictate. Secure by design, it is very secure. In terms of SGS technology or PTN technology, it is very secure. So it's a high level of privacy and security through the hard partitioning of traffic onto a dedicated circuit. This segregation of network traffic makes it difficult to intercept data transferred between the nodes over OTN channelized links. Robust but yet simple operation. No other technological solution allows an operator to turn up the new service faster and more efficiently while removing the cost of uncertainty from the future traffic matrix. So that is all about the MS-OTN. Now I will talk about the solution in MS-OTN. Okay, so compared to the OTN port level processing, MS-OTN added identifying different services in a single port. The port or service aggregation supports complex service type such as MP2MP and dual domain protection. What is protection? Like service running from a certain path and it there is a fiber cut at that part, the service need to be switched to the other route. So it is done logically, and it calculates the routes in advance, and the signal switch to the other network. QS. What is QS? QS is introduced to provide differential classes of services based on requirement of different services, such as voice services, video services, and data services. QS has following merits. It provides dedicated bandwidth for a specific user or service, avoids and manages network congestion, reduces the packet loss ratio, and grooms network traffic and improves bandwidth utilization. Basically, in earlier, the traffic and bandwidth utilization is not up to the mark. But using this QS technology, now OTN is very smart and it can use bandwidth very efficiently. So it avoids network congestion and packet loss ratio, and improves the bandwidth utilization. QS, the set of techniques necessary to manage the bandwidth, delay, jitter, and packet loss. So this is the signal rate. I earlier also said the OTM1 can serve 2.5G of data payload, and basically the size of the packet is 2.66, but that is the frame structure. If you will see the overhead, due to overhead it is 2.66, but actual data payload we can use is 2.55. Similarly for OTU 10G we can actually use, for OTU4 100G. So, this figure basically highlights where OTN fits in the network, providing sub-wavelength bandwidth management and decoupling service rates from the line rate. It also highlighted how OTN encapsulation provides agile transport for high-capacity client services of various protocols over a photonic layer. So basically, this is OCH. I have showed in the picture. After digital wrapping OTN framing, there is a single word, that is OCH, or channel, which carries the bandwidth in terms of carrying between 100G, 200G, or 400G nowadays. Previously, it was 40G, 10G, 1G, 2.5G. Underlying the structure OCH, there is a OMS system. Okay. Then there is underlying OTS. And this is the fiber, and this is the optical amplifiers. So this all about the solution in MS-OTN. Now I will tell about the network planning strategy. So how to plan a network in terms of strategy wise, how to plan the terminal, ROADM, and OLA side. As I earlier said, a system deteriorates after traveling 60 to 80 km depending upon the fiber health, or the difference of loss. The fiber loss is the major point we have to consider. So starting from a terminal side, there are certain number of OLAs to reaching a terminal B. Like we have started traveling from Delhi, and we have to travel across Mumbai or Hyderabad, that is 1700 kilometer. In between, there are multiple number of OLAs. Why this OLA required? To regenerate the signal. If signal start traveling from the terminal A, that is Delhi, so after 60 to 80 kilometer, the signal will be deteriorated. Okay, so after that distance, we require an OLA. Then again traveling that OLA 60 kilometer, we again require a second OLA to regenerate the signal. The standard fiber loss for fiber is 0.25 dB per kilometer, which varies to 0.3, 0.35, 0.4, up to 0.5. Okay, so how these fiber losses increases? Because of splicing, the impurities, okay. So what is the core and cladding? So depending upon that factor, this fiber loss is calculated. But for the standard loss is 0.25 dB per kilometer. I will tell you the example. If one fiber having 0.4 dB per kilometer loss, okay, and the span length is 60 kilometer. For example, what is the span? The distance between an OLA terminal side, or distance between an OLA and OLA side, or a distance between OLA and ROADM side is called a span. So I'm taking an example. If its span length is 60 kilometer and the fiber loss is 0.4 dB per kilometer, then the total loss for that span will be 24 dB. That is multiplication of this distance to the fiber loss per kilometer. Okay, so this total loss for this fiber is 24 kilometer. It can be acceptable up to 28 or 30 or 35 dB depending upon the OEMs. Okay, what type of cards or amplifiers we are using. So maximum we can use 30 to 35 dB loss accommodate per span. But nowadays to accommodate high bandwidth 200G channels, 400G channels, the losses, the maximum we can bear per span is 28 dB. Okay. So moving to the next generation, like if you are using catering 800G channel, the span loss maybe acceptable will be 24 dB. Okay. So this is the diagrammatic representation of Lucknow to Noida. I have earlier told you. Okay, this is the terminal sites, this is the Ola sites, and that is the ROADM site. So with this diagram, I will show you the ROADM application. What is the function of ROADM? Okay, a signal is just a minute. So a signal started traveling from Lucknow to Noida via this path. Okay, at Sitapur, Hardoi, Shahjahanpur, Bareilly, Muradabad, Hapur, signal will be regenerated at these junctions, and ultimately it will fall to Noida. So if this is the fibers connectivity between the Sitapur, Hardoi and these the Ola locations or ROADM locations. Let us suppose there is a fiber cut between Muradabad and Haipur. Okay, the fiber is cut. So how will travel this signal to Noida now? So in between there is a ROADM site. It can switch services based upon the available best path and the shortest route calculation. So now will signal was traveling previously like this. Now till Bareilly it will reach, and rather going forward it will detect a fiber cut. So it will switch the services automatically to this path to reaching Noida. This is the function of or application of ROADM system. It switches the services automatically in case of fiber cuts, fiber degradation. Let us suppose there is again another fiber cut, Sitapur to Hardoi. Now the signal start traveling from Lucknow to Sitapur, but it cannot go forward because there is a fiber cut. What will do? So signal will automatically switch to this path, and now signal will run through this secondary path. So there is a number of paths we can define in an optical system. Okay, so generally there are the switching mechanism. One is SNCP. In that we provide two paths for a particular service, like from Lucknow to Noida or Mumbai to Delhi. 100G bandwidth is required for Amazon, Facebook or Netflix customer. Okay, so to carry this 100G bandwidth, if there is a fiber cut in path 1, we can switch the services to part 2 using SNCP technology, switching technology. And it customer is dedicated on 3 paths that it is called SON services. So let us suppose if there is a fiber cut in path 1, if there is a fiber cut in part 2, then service will switch to the third path, and it might go to carry the third path. What are the third path available at that time? Like it will go to Lucknow to Varanasi, Varanasi to Patna, and then Patna to Noida via some other routes. So SON and OVPN is basically 3 paths are available for a particular service. So what is the evolution of networking? Phase 1, point-to-point networking, 60 km of transmission without electrical regeneration. Phase 2, ring networking, 2000 to 3000 km transition without electrical regeneration. Phase 3 is mesh networking. Okay, here we can travel signal 4000 to 5000 km transmission without electrical regeneration. What is the capacity for terminal sites? I have tell that depending upon the guard band or channel frequency spacing number of channel to be accommodated. If you are using 100 gigahertz channel spacing, we can use 40 channel. If we are using 50 gigahertz, we can use 80 channels. And if you are using 25, we can use 160 channels. But the less the frequency spacing, more will be the interference, and the noise impurity will deteriorate signals, and signal generally talking to each other. But we don't want this in optical system. That's why channel spacing and guard band to be set. And currently we are using 100 gigahertz and 50 gigahertz to transfer or traverse the this channel. So what is channel spacing? Now I will tell. This is the three frequencies 192.3.4 and .5. The frequency or channel spacing is 100 gigahertz. With 100 gigahertz, we can accommodate 40 channels over a system. In WDM network, each signal on a fiber given a fixed bandwidth in order to avoid interference between the signals. Okay, these are the two different signals. To avoid interference, a fixed spacing is maintained, that is called channel spacing or a guard band in WDM signal. Okay, so it can varies up to 10 gigahertz to 100 gigahertz. Current scenario, we are using 100 gigahertz guard band and 50 gigahertz bandwidth. So this is the channel spacing and the bands in which we are using, and the wavelength count, or we can call channel count, and this is the maximum rate, and this ultimately gives the capacity. For example, I will tell you the 100 gigahertz band in C band. Okay, number of wavelength count is 40, and maximum rate is 10G also, 100G also. So if you are using 10G channels, the capacity will be 400G. If the channel maximum rate is 100G, then there will be the 4 terabyte bandwidth can be used using this 100 gigahertz channel spacing. Technology enabling new architecture. Router capacity increases multifold. Previously, the bandwidth is very less. The signal carrier rate is STM1416. Nowadays, we are using 100G channel, 400G channel. So in recent industry announcements outline performance capacity greater than 4 times the largest platform with a fraction of the footprints and power consumptions. These units based on the new network processing unit and enable multiple terabits per second capacity are opening new doors to opportunity for new services. Commoditization of coherent optics. With OTT, web scale and service providers moving to a coherent optics at 400G distance above 10 km. Along with the standard efforts, increases the adoption rate and enable high volumes not seen even before. So, I will tell you the inference, how coherent detection and technology is used. As an interface data rate increases requirement for the coherent technology at shorter reaches the mover deeper into the network. In 2 km, first there is a reach for 100G, 400G is direct detection. But we increases the distance, the direct detection reduces to the 400G. For 40 km, it reaches to the 100G. But as we use coherent detection, we can use above 80 km and we can reach the capacity up to 1.6 terabyte. So the coherent technology is the next advancement which are using for the OTN service. So what is coherent communication? All you aware of that, and you studied as well that the coherent light consists of 2 light waves that which have an oscillation direction, same oscillation direction and same oscillation frequency. After the interference is produced, the amplitude is the strongest at the peak to peak and trough to trough. Okay. What is the essential of coherent communication? High speed ADCs, okay, advanced modulation, PDM and QPSK, okay. The coherent receiver system can theoretically increase the OSNR by 3 dB. High speed DSPs, which dispenses the PDM compensation capability, and the FEC algorithm improves the OSNR and the high performance FEC. These are the 5 key essentials for coherent communication. So there is a difference between coherent and non-coherent. Earlier we are using non-coherent, now we are coherent using. So first difference is that in coherent system, the requirement of dispersion compression modules are not required anymore. In non-coherent system, previously we used dispersion compression module to compensate the fiber impurities, the noise, the interference. But in coherent system, it will automatically take care of these noises and impurities. Okay, it is having a very high polarized modulation tolerance in comparison of non-coherent system. It having better OSNR, optical signal noise to ratio, in comparison to non-coherent system. Rerouting is not restricted by dispersion, it's more reliable. Rerouting, what do you mean by this? I have earlier said that if there is a fiber cut in a path 1, then services can switch up to part 2. So in non-coherent system, it is restricted to the dispersion, but in the coherent system, it is not restricted to the dispersion. So services can switch at any time. It can proactively calculate the best path, best route on which service has to be switched. So what is high capacity device application? So single span DCI. This is the access layers, the metro layers, that 800G we can use per wave. There's a multi-span metro long haul network between the cities, major cities. Okay, here best in class network, economical, tunable 200 to 800 capacity, and this long haul have fewer ways to manage. Then there is a submarine network also. Okay, so it can use 400 GB, best in class, less ways to manage, ability to maximize return on cable investment. As coherent moves deeper into the network, adoption rate increases, and where the 3 years might be on par till 2023, this will number increases in multi-force. In 2014, 100G coherent network is used. Okay, in 15, the capacity increases to 150G, then 16, 200G. Then in 17, there is a coherent 200G system came into the application. What is the difference between these? Over a particular frequency like 192.1, we can use only 100G maximum capacity channel rate. Okay, so we can use 40 channels of 100G. But in 2070, system advances, and now we can use a single frequency channel up to 200G also, with the hybrid combination of 100G and 200G. Now in 2020, we can use 400G channel also, 100G also, 200G also. So in 2023, we can use this hybrid system. Depending upon the requirement, we can use 100G, 200G or 400G signal, and this can be multiplied by 80 as I will tell you that depends upon the channel spacing. So this all about this technology I want to share you. So over to you, sir, and thanks for giving me opportunity to access my field. Okay. Hi, Anamika.
Thank you so much, sir. Thank you so much, sir, for creating such an enlightening session for all of us. It was very productive and interesting to hear to you, and we've been fortunate to have you here. Thank you. Now I'd like to remind all the participants to join their respective tracks, that is track 4 and track 5, with the links provided to them. Thank you.